Hi there, Mr. Sutton back again with another lesson on inequalities. We're going to take things up a level by doing compound inequalities in this one. Specifically, we're going to find solution sets when we have an AND or an OR statement. And for a real-life application, we'll do that one right away. Students are going to find the ideal height for a date. Let's get going. Let's say we have a girl named Extrema looking for love. She's posting a personal ad online where she says that she wants somebody who's under 5 feet or somebody who is over 6 feet. She likes really short or really tall. How can we express her height preference? Now, you might have noticed this is a little bit tricky to do with single inequalities because under 5 feet, that's kind of like going left on a number line, and over 6 feet, well, that's kind of like going right on a number line. We're going like two different directions here. How can we do that with one inequality? The answer is we can't. We need something called compound inequalities. Compound inequalities are actually two inequalities joined together using an AND or an OR, and those two things do different things. For example, with an OR statement, these statements give you all the places where either of the two inequalities is true. This is really helpful if you want to shade outside 2 points. For example, let's say that we write Extrema's preferences here as x less than 5 or x greater than 6. She wants someone shorter than 5 feet or taller than 6 feet, and she's happy with either one. Now, to graph that, you've got open dots for both of these because there's no equals in the inequality, and here we're going left from 5. Here we're going right from 6. So this kind of statement can give you inequalities that are in two different places, which you otherwise would not be able to express. So let's say that we're given something in OR form already, and we want to figure out the exact solution set and graph for it. The way to tackle these is to solve and graph each of the inequalities individually. And you're usually going to have to shade outside 2 dots. Not always, but most of the time that's what these are used for. So take a sec, pause the video, and solve each side here individually. The left side and the right side. Okay, now that you've had a chance to solve those, let's do the left side. So we had to add 8 over here for negative 21. Divide by 3, dividing by positive so we don't reverse the inequality. That's x less than or equal to negative 7. And let's finish off this other side. Subtracting 16 gives us 64. And then dividing by 16, again, no reversal of inequalities. That'll be x greater than or equal to 4. And now we're going to go ahead and graph both of those. Make sure you put these in the right order. Don't assume that the number over here on the left is actually going to be to the left of this number on your number line, so double check. Negative 7 does happen to be to the left of 4. We have a solid dot on negative 7, and we also have a solid dot on 4. Don't assume they will be the same kind of dot. You have to look at each individual inequality. So there are our 2 solid dots. Here we're going to the left of negative 7. Always double check, don't assume. And here we're going to the right of 4. Now we actually need to write a solution set. This isn't enough the way it's written, so that's very easy to do. You're just going to stick an OR between your 2 inequalities, and that is your solution set. You could even be lazy and just write it up here. You could have written it all the way down, but that's maybe a bit much. We're going to shift our focus to AND statements now. An AND statement includes everywhere where both inequalities are true. So this is really good if you want to shade between or inside 2 points. For example, let's say I have the inequality x greater than or equal to 5 and x less than or equal to 6. So maybe this is another person who wants people who are taller than 5 feet and less than 6 feet at the same time. So we've got solid dots on both of those numbers, and greater than 5 and less than 6, the only place that meets both conditions is between the 2 dots. And I mean, notice that this stuff over here is also greater than 5, but it's not less than 6, so we're not allowed to include it in our solution set. Let's go ahead and graph one of these AND statements now. It's going to be similar to the OR statement in that you're tackling each of these 2 statements individually. However, after you solve those inequalities and graph them, you have to shade a little bit darker where they overlap. or just don't shade where they don't overlap. Usually that'll be inside the two dots, but again, always double check. So we've got 6 minus 4x less than or equal to 30, and we've also got this other one over here that we'll solve in a sec. Take a sec to go ahead and actually solve those individually. Okay, so over here on the left, we can subtract 6. That'll be 24 on the right side. And then we'll divide by negative 4. That'll be x. We got to reverse because we're dividing by a negative, so x greater than or equal to negative 6. Over here on the right, we can subtract that 8 for negative 13. Dividing by 13 gives us x less than negative 1. So let's go ahead and graph these. Now, negative 6 is to the left of negative 1, so we can put the negative 6 over here. That's going to take a solid dot because of the equals. Negative 1, notice, has an open dot because there is no equals on this. And in terms of where we're shading, we want everything to the right of negative 6. That is also to the left of negative 1. So we end up shading between those two things. For writing the solution set, you've got a choice here. One option is to just stick an and between your two statements, like you could put the and right here and circle it and call it a day. Another way to write this, which is useful because you'll sometimes see things in this form, is in what I like to call smaller, less than x, less than bigger form, or double inequality, double less than form. So the way you can do these is you start with the thing that's the furthest to the left, which is negative 6. You put the correct type of inequality based on the dot, so that would be a less than or equals to. Then you write your variable, x. Then you put another less than and the bigger number. So negative 6 less than or equal to x less than 1. And if you actually read this, this is saying negative 6 is to the left of our solution, and our solution is to the left of negative 1. So it literally goes from left to right. That's why these both have to be less than symbols. Now, some of you might be thinking, well, that seems like a little bit of extra thinking. Why should I do that? It's good to get in practice because you'll sometimes see things in that exact form. And if you practice writing things in this form yourself, then you have an idea of what this means. So this right here is actually an and statement in disguise. This really means 0 is less than 9x plus 90, and this stuff in the middle, 9x plus 90, is less than 18. So if you are going to solve this like a normal and statement and kind of do it the long way by rewriting it, make sure that you use that stuff in the middle twice. It is part of two separate statements. But it's actually a lot faster just to solve all three sides at the same time. So if we were going to go ahead and solve this, the first thing I would do to get x by itself would be to subtract this 90. I just have to make sure that I subtract 90 not just over here, but also over on the right side as well as in the middle. So that would be negative 90 less than 9x less than whatever 18 minus 90 is, negative 72. Next, I have to go ahead and divide by 9 to get x by itself. Again, I'm going to do that to all three sides. So this will be negative 10 less than x less than negative 8. And that is significantly faster than doing those two steps in two different inequalities. To go ahead and graph this now, just get your dots correct. So we've got negative 10, negative 8, both open dots. And we're just going to shade between. We're always going to shade inside with these double less than statements. So right here, and the reason we're always shading inside, because these double less than statements are always written from left to right. So if this thing on the left is always to the left of your answer, and your answer is always to the left of the next number, you are always going to end up shading inside. So that's it for this lesson. Just one final thought to leave you with in case you were wondering. There is no shortcut form like this for or statements. Or statements, you always have to write them with an or in them. But and statements, you do have this option. So until next time, this is Mr. Sutton signing off.